Hi, everyone. Nice to see you here. My name is Nadav. I'm a developer at Microsoft. Here today with me are Ari, my colleague, and Guy from InSounds. And today we're going to talk about an object detection project that we did together with InSounds. And we're going to start off with Guy, who's going to tell us a little bit about InSounds.
Hi. So my name is Guy, and I'm the CEO and co-founder of InSounds. InSounds is reimagining the viewing experience of live sport and media event broadcasting, as well as the VR side. Some context. We graduated the Microsoft Accelerator program last January, and as part of the program, we shared with Microsoft the need to tag and detect objects within frames or within video. And we're happy that the development team took the challenge on that, and they will share more about what they do. Going back to what we do, we're using multiple technologies, anything from audio processing to sensing to machine learning and computer vision. And we're doing all of that in order to capture sound anywhere in a given space. If you think about sports, you have a stadium and you have multiple players, coaches, referees, and a lot of places where actual game action sound is being produced. Now, we would like to capture everything and deliver that in real time to the broadcaster. In order to do that, we start basically with microphone arrays. Microphone arrays means an array and a form factor, be it a laptop size or any other size, with lots of digital microphones. Small ones in a dime, US dime, you can probably fit 5 of these microphones. We fit tens of or hundreds of microphones into an array. And then we're using, sorry about that, we're using software to do 2 main operations. The first one is to zoom in on specific places of interest for us and capture audio. Now, as you can imagine, in a sport arena, it's very noisy. So at the same time, we have to learn the noise, not only the level of the noise, but also the distribution, where the noise is coming from. And once we learn the noise in real time, we know how to cancel it. The 2 operations together enables us to capture any sound anywhere, and can be multiple sources happening at the same time. Now, one of the challenges that today we're using predefined locations for audio capturing. Now, don't get me wrong, we can still do it on the fly. Okay, we don't have to predefine the locations ahead of the game. We can do it simultaneously as the game is going. But for a future need, we would like to be able to detect objects, sources of audio, and then do the capturing automatically, and building on top of that, also be able to track the objects, whether it's people or the game where the action is, as they move across the field. And then we deliver that, obviously, when we capture it, we deliver it to the production team, whether it's a linear broadcasting producer, a digital one, or a VR. We do it live, but we also record all the audio for post-production, whether it's live replays, post-game footage, and so on and so forth. Okay? So let me show you how this looks like. Should I?
Starting things off, it's in right field. Orlando starting things off. Right field today. Off his first full year in the big leagues last year. Off his first full year in the big leagues last year. their plans going forward. You know, a lot of free agents about their plans going forward. You know, a lot of free agents.
Wind here is so weird. Flags are blowing dead end, and the breeze feels like it's 30 mile an hour in my face. Right there, yeah.
So to summarize, our end goal is basically to fit each video feed with the relevant audio so people can actually enhance the experience, the understanding, and the value of the video itself. With that, I think it's the right time to let Ari and Nadav take the stage and share with you their development and the ability to tag and detect objects automatically in frames and video feeds in general. Thank you.
Okay, so thank you, Guy. And so when you talk about object detection, people often start with object recognition, basically. So object recognition is when you try to identify what's in the picture. And when you come to think about detection, then you also try, in addition to recognizing the object, to actually say the location of the object inside the picture. So for example, here we're trying to also say where the cat is. And today, most object detection system uses machine learning, uses deep learning to do that. And you know, as a lot of other machine learning approaches, this kind of thing also needs data and label data in order to do that, in order to learn from examples. And the way that the data looks like in object detection system is basically this group of images with objects, where each image will have the location of the object and the type of the object inside. And in our project, we used CNTK and an algorithm called FastRCNN, which stands for Fast Regional Convolutional Neural Network. This is an algorithm developed by Microsoft Research 2 years ago. It achieved state-of-the-art results on object detection. And the way that it works, it builds on top of object recognition system and uses a method called transfer learning in order to build on top of an existing neural net and build other neural nets that can detect objects. So it receives basically an input image, runs it through the network, and then gives you a collection of detections for that image. And it uses the data that we've basically shown in the previous slide of the images and the boxes. So using that is quite, oh, here we go. So training such network using CNTK is not that hard. You have some nice resources online, including a very nice tutorial by the CNTK team that you can use, which basically walks you through the process of building such system. So it's basically just running a few Python scripts after you get the data set up. It's not that hard. And it gets some nice explanation about the algorithm itself. On our side, what we did here was to develop this basically Python notebook example that can also run you through the process of taking a single image, running it through the network, through the model that you build, and then giving you the detections. The example that they have basically lets you, take images out of a fridge and find the groceries and the grocery items that are in the fridge, basically, in there, and it runs you through the different steps. Another thing that you can use is this Python library that we built that basically lets you, with very simple Python API, as you can see here, with a few lines of code, you can just call the model, basically just load the model up, load an image, and then run the detection and get the different parts of the image that corresponds to the different objects. So this is nice, and it's really, once you get the data ready, it's not that hard to do. And the problem with this kind of projects, in most cases, is that you don't have good data sets. And you don't have proper images, and you also don't have the actual locations of the objects inside those images. So this is why we spend a lot of time in this project on developing a tool that actually lets you build those kind of data sets. And I'm going to give the stage now to Ari, who's going to explain you all about it.
Perfect. Thanks, Nadav, for that introduction. Can you guys hear me? All good? All right, perfect. So to understand a little bit the tool that we built, we originally have to understand the traditional tagging process today. So traditionally, when you're building these object detection models and leveraging transfer learning, you need to have your own representative tagged image data set. So in InSound's case, we worked with baseball videos, and we need to tag these videos. Well, traditionally, when you're tagging these videos, you'll take a couple videos, or maybe even more than a couple videos. You'll send them to some people, and they'll go and they'll manually tag through each of these videos. They'll send you the data back. But there's a problem there. That actual compilation and tagging of the data is independent from the model training. So you don't necessarily know after a while, after you've optimized your model and gotten all the information gained from the data that you have, whether additional data is actually providing any additional information gain. So to understand this problem better, let's talk about the optimal way to do object detection. What you'd really want to do is you'd want to be able to tag, let's say, one video or an image directory and get the regions of interest there. After you do that, you're going to want to export those tags in the format without having to worry about what the framework you're using, whether that's CNTK, whether that's TensorFlow, whether that's AlexNet. You just want to be able to export so that you can train a model. But here's where it gets interesting. Traditionally, when we evaluate these models, we use the traditional ML evaluation metrics, but that makes it hard for us to visualize when our model is ready. What we really want to do is we want to have a tool that allows you to evaluate the model on a new video, so that way we can validate its performance, and it's in the tagging tool itself, so that way we can update the labels that are wrong, and it minimizes the amount of work that we have to do, so that when we're done, we can just reiterate through this feedback loop until we have a model that's ready to perform it. So in order to help people with this process, we developed the visual object tagging tool. I'm going to give you guys a short demo to show you kind of how this works today. So let me just swap over the computer here. All right, perfect. So to get started, you can search object detection in a box. We have a really nice code story. And you can go here to VOT, catalystcode.vot in GitHub, and you can download the project in the releases. There's a really nice tutorial on how to use it. I'm going to show you it right now. So I have a version that I've already downloaded. I'm going to pull it up here. Very simple. It's an Electron application. Works on Windows, Linux, OS X. To get started, I'm just going to load in a video. So I'm going to load in a video of baseball. And there are a couple simple configuration settings. The default values are pretty good, but they provide some novel features that you don't see in most tagging tools that are out there. So the first thing is the frame extraction rate. Usually when we're tagging videos, most tools make it so that we have to tag all 60 frames if it's 60 frames per second, or all 30 frames if it's 30 frames per second. But what you see very, very quickly is then you end up having data that's very similar to each other, and you're not maximizing your information gain for the amount of tagging work you're doing. So what we enable you to do is to, first of all, configure how many frames you want to extract for a second. The next thing we do is we have the region type. So this allows you to decide whether you want to have an auto-fixed bounding box or you want to have a variable-sized fixed bounding box for training your models. And then an additional really nice feature that we added, especially for videos, in traditional tools, you have to go and you have to tag every frame individually. But what's really nice is we have tracking algorithms that exist. Shouldn't we be able to just tag once, and then as we go through each frame, be able to leverage the information that we have in the tags? Obviously, we should. So we provide a couple different tracking and suggestion methods using CamShift, and also the ability, if you want to, if the frames are close enough that you can just copy from the last over. So now I'm going to show you a little bit how the tool works. I'm going to put in some labels to tag. We're going to put in player and let's say head, right? So what you'll notice here is we have the tool, we have our tags down here. And what's really nice also about this tool is it's responsive. So if I have a large screen or a small screen, I can maximize the screen real estate. And when I export, all that information is automatically translated to the format of the model tool that I'm going to be building. I can now go and let's tag the person's head. And now as I go through each of the frames, it's auto-tracking for me. So if it's a little bit off, I can move it around, I can resize, but it minimizes the amount of actual manual work that I have to do tagging my data to build new object detection models. Now here's where it gets really interesting. Now let's say we've done some tagging and we're ready to go. I want to train this model. What I can do is just export tags. Out of the box, we support CNTK, FastRCNN, but also we support the YOLO, you only look once framework that allows for a different object detection model. So just to explain the differences between the two, FastRCNN typically provides you more accurate results, but YOLO allows you for more real-time results when you're evaluating. Then we can decide up to what point we want to export our tags, and we just click export. So now you saw very, very fast we exported our tags. I'm going to show you kind of what that looks like. So I'm going to go here to the folder where that is. And you'll see already I have all my data formatted so I can just point the scripts or the notebook just to this directory, click train, and I don't actually, if I'm not a deep learning expert, I don't actually have to configure the model. I can just configure the data. Now here's where it gets interesting. In addition to this as well, we have a feature, as I explained with the end-to-end pipeline earlier, that allows me to, let's say, load a new video and evaluate a new model. So I can point to a new path, and what's really nice here, I'm not going to run the model for you now because this computer doesn't have a GPU, but I have a model that I've already run. And what you'll see here, again, these are different tags. I didn't do this earlier, but what you can see here is very easily, I can see and go through and evaluate my model. If it's a little bit off, again, now I can, in real time, see that, look, instead of having to now tag 5 frames, I only have to retag 1. And as I go through and now export and retrain, I'm reducing the amount of tagging work that people will have to do, and I'm also maximizing knowing that everything I tag adds information gain. So again, I really wanted to thank you guys for being here and seeing the first demo of this tagging tool. Just a couple resources to get started. We have a couple of blog posts that we've written on our blog, microsoft.com/real-life-code that you can use to get started. You can just fork this or clone our repo, and you can also, we also have prepackaged Electron bundles that you can run on your platform. We really look forward to getting your feedback on this tool. It worked really well with InSounds, but again, we monitor issues, we monitor pull requests, and we're looking forward to seeing this be something that the community can use to actually build object detection models, and we can't wait to see what you built. So again, thank you, and I hope you enjoyed.